In this lesson, we're going to be multiplying polynomials. Example 1, how do I multiply a monomial and a polynomial? So in the last lesson, we were adding together the polynomials. Today, we're going to be multiplying them. I just want to point out that if you are adding together the terms, that the exponent does not change. So if I were adding all of these together, I would then have 1x plus 1x plus 1x is going to give me the 3x. We don't change the x or the power on the x, we just have the 3x's. Same thing if I had something like 2x squared plus 3x squared. We're not changing that x squared, we're just going to have the 5x squared. But today we're going to be looking at multiplying and remembering the rules for when we multiply exponents. If I have something like x to the second times x, remember we're multiplying it. It's like having two x's multiplied together and you're having that third x. So we're going to be changing the exponents today in our lesson. All right, so we're going to start by distributing this 3x squared times to each one of these parts within that parentheses. And remember, when we multiply the exponents, when you have the same base, you're adding those exponents together. So we're going to take this 3x squared and we're going to multiply first the 2x to the third. 3 times 2, you get your 6. And then remember that that x squared and that x to the third, it looks like this. 2, 3. And we have x to then fifth power, because I've got 1, 2, 3, 4, 5 x's. All right, so now we're going to multiply. So we did this here. We're going to multiply this right here. I have 3x squared times negative. We're going to take this entire piece right here. So I have a negative 1, so I'm going to have negative 3x to the fourth power. And 3x squared times 4x. 3 times 4 is 12, and x squared times x is going to give us x to the third, and then now we're going to multiply it by the negative 3, and so we're going to have negative 9x squared. So example 2, how do I multiply polynomials using a table? Notice that you have two expressions that have more than one term, so we're going to be multiplying the x to the fourth times the 2x minus 1. So we're going to look at a couple of different ways that we can solve problems like this. One of the ways is by using a table. Some of you might want to make a table all the time, and some of you may never make a table. So when you make your table, you're going to want to have a table then, because you've got binomials. You're going to want two that are going on the top, and then you're going to want 2 sections that are coming onto the bottom, because they each have 2 parts. So I'm going to start with this x plus 4, and I'm going to line up the x and the 4 on the top, and on the side I'm going to have the 2x, I'm taking it from here, and I'm going to have the negative 1. So I'm going to start by multiplying our x by our 2x, giving 2x squared, and then we're going to multiply our 4 and our 2x, giving us 8x, and then coming over here you'll take your negative 1 times your x, negative 1x, and then we'll take our negative 1 times our 4 and give us a negative 4. And once you're done multiplying, now we can combine, or we're going to take out the terms. I have 2x squared, and then notice how you have these two right here. I have 8x and negative 1x. That's going to give us a positive 8x, and then we're going to have left at the end our minus 4. All right, let's take a look at our next one. We have b squared plus 6b minus 7, and then we're going to multiply that by 3b minus 4. So because the first expression has 3 terms, we need to have 3 across the top, and then we're going to have 2 rows. So let's go ahead and we'll get ours set up. I'm going to have b squared, and I'll have 6b minus 7. And then 3b and negative 4. All right, so let's start multiplying. We're going to take our 3b times our b squared, giving us 3b to the third. And then we'll have 3b times 6b, we'll have 18b squared. And 3b times negative 7, you'll have negative 21b. All right, so now let's come over to the next row, and I'll be multiplying the negative 4 times all the terms that are on the top. So I have negative 4 times b squared, giving me negative 4b squared. And then negative 4 times 6b is going to give me negative 24b. And then negative 4 times negative 7 gives me a positive, then now 28. All right, so let's go ahead then, and we're going to combine our terms here. Now notice how across from these are the ones that are going to be combined as we then write it out. So we're going to start, then I'll have my 3b to the third, and then I have 18b squared minus 4b squared, so that's going to give me plus 14b squared. And then I'm going to take my negative 21b and combine that with my negative 24b, giving me a negative 45b. And then we have that last one on the end, plus 28. And now that we've combined everything, we are done. All right, so how do I multiply polynomials horizontally? Regardless if you're using a table or if you're going to be multiplying it horizontally, you are taking the first term in your parentheses and multiplying it by the second. So each part is going to get multiplied or distributed to the next expression. So I'm going to take, and I'm going to multiply then, and I'm going to take 6x squared times 7x. And that's going to give me 42x to the third. And now we have to take this first term again, and we have to multiply it here. And I'm going to take 6x squared times negative 5, giving me negative 30x squared. So then when I'm done with the 6x squared, I'm going to move on, and I'm going to do the same thing with that 3x. So I'm going to multiply then 3x times 7x, and that's going to give me 21x squared, and minus 15x. All right, so now that you're done with the 3x, you move on to the next term, and we're going to then multiply the negative 1 times 7x and negative 1 times negative 5. So negative 1 times 7x gives us a negative 7x. And then now I have to multiply again, and I'm going to have positive, negative 1 times negative 5 is a positive 5. And now when you're all done with this, we need to go and combine any like terms that we have. So notice how I have negative 30x squared and I have positive 21x squared. So let's then, we're just going to have the 42x to the third, and then negative 30x squared plus 21 gives us a negative 9x squared. And notice how we can combine here. Our negative 15x minus 7x gives us a negative 22x, and then plus 5. And once you've combined all your like terms, then you are all done. All right, so let's go ahead and take a look at a method that we call the FOIL method. This one we're most specifically using when we have two binomials, two terms within each parentheses. And so the FOIL stands for the first, the outside, the inside, and then the last, the FOIL. And really it's just a horizontal method, but it's a way for us to keep track of the parts that we are multiplying. All right, so we're going to start with the first, the F, where it's the first two terms in each of these. So I'm going to have 4a squared. And then the O for the outside refers to the two outside parts. And that's going to give us an 8a. Then we're going to look at multiplying our 2 on the inside, which is going to give you a 3a. And then last of all, you're going to multiply your last two terms. So I'm going to have plus 6. And then just like before, we're going to combine our like terms. So I'll have 4a squared plus 11a plus 6. All right, let's take a look at these next two binomials. And I'll just write the FOIL up here, FOIL. So again, the F stands for multiplying the first. So in each of these, you're going to take the first term, and so I have 12x squared. And then the O represents multiplying it with the outside too. So remember, these are both on the outside of each of the sides. And so we're going to have minus 24x. And now the I is for the inside. So we're going to multiply these two. And that's going to give us 4x. And then the L stands for the last two terms. So then we'll have negative 8. So now let's put it all together. We have 12x squared minus 20x minus 8. And once you've combined everything, it's all finished. All right, so how do I solve polynomials in geometry? So let's write a polynomial for the shaded region. And so we're looking for the area here. So let's take a look and let's look for this area right here. And notice how this side is an x and how the right here is an x. All right, so we're going to find the area for that shaded region right there. And x times x is going to give us an x squared. So we'll have x squared here. All right, so then I'm going to bring this 4 up top here. So the 4, this is going to be the length of this side down here. So we're going to take the 4 times the x, and we'll just get then the area of that region is 4x. And I'm going to move this 2 over here, right over here. That means that that's the height of this side. So we'll take the 2 times the x, and that's going to give us an area of 2x. And then we're going to take 4 times 2 in the last part, and we'll have 8. Now we just need to put it all together. And we'll start with our x squared. And so we'll have x squared. And now notice how these two can be combined together. And I'll have plus, and we're adding these, combining the like terms, 6x. So 4 plus 2, and then x plus x. I'm sorry, just the x's. And then we'll have our last term, which is going to be an 8. And once you've done that, you are all finished. All right, so now we're going to find the area of this rectangle here. Notice how it has a rectangle on the inside of it that has been whited out. So we're going to start by finding the area of the rectangle on the outside. And when we do that, we're going to take the 9 times the 15. And when we do that, so we have the 9 and the 15. We're finding the area of the entire piece. And that's going to give us 135. And now what we need to do is to remove then, we've got this piece on the inside that's been whited out. And so because it's been whited out, we have to take it away from that. So it's going to be minus 15, then x squared. And because these are not like terms, we're just going to leave it like this. So in this lesson, we took a look at how to multiply polynomials.